In chapter 5, questions can be something like, let me go to the slides. Okay, so you already know about questions which are something like this one. We have said that if we change the order, what will be the output? So that can be one example of questions that you have already seen in the quiz. Okay, so this is one type of question. The second question is about I can ask you simply, what are the solutions to critical section problem? For example, what are the conditions? So you can write the conditions which are required: mutual exclusion, process, progress, and bounded weighting. Okay. Similarly, I can ask you what are the good things, advantages and disadvantages of Peterson's solution. Okay. So one disadvantage of Peterson's solution is that it is only used for two processes. If there are more than two processes, you cannot use Peterson's solution. This is one problem. Okay. The good thing about Peterson's solution is that it does not require any hardware. Okay. This is simple algorithm. This is also very good thing about it. Okay. So something that can say what is the advantage of Peterson's algorithm, or what is the disadvantage of Peterson's algorithm. Okay. Similarly, I can ask you about not these things. Okay, this is easy. This is not. But maybe I can write you to give the code for mutex logs. Write down the definition of the acquire and release function in the mutex logs. Okay. So you have to know how does the mutex log work. For example, how do you write the acquire function? What is inside the acquire function and what is inside the release function? Okay. Similarly, same I can ask for semaphore. Write the weight and the signal operations for semaphore. And this one is only for example, binary. I can ask you to consider 10 things, 10 integers. Okay. So it can be a code in which we start with 10 objects or with 5 objects. So what will be the difference? Similarly here, I can give you this, what is the problem here? Okay. Or I can give you that I have these processes, this is the code. How can I change you the code so that there is no problem? Okay. So what is the problem here? Deadlock condition. How can you avoid the deadlock? How can you change this code to make it so that there is no deadlock? Okay. So these are the basic questions that I can ask you. I can ask you the difference between starvation and deadlock. What is the difference between them? I can ask you, for example, what is priority inversion? Okay. And how can priority inversion help us? So these are the questions that I can ask you. In the assignment 2, I asked you about dynamic philosophers problem. So I don't think I'm going to ask you anything about dynamic philosophers. That's all about chapter 5. I cannot think of any other question right now. Your question is that how can we solve if there is a deadlock here? What you see here is that this process, it will acquire, or it will be waiting for S, okay, and this one first it will get Q. Now if this one it gets S, okay, and this one it gets Q. So P0 is waiting for Q and P1 is waiting for S. So they are both waiting for one another. What we can do, let's say, if I change this S and Q, if I make Q before S, okay, so wait for Q, then wait for S, what will happen? If anyone it gets Q, then the other will be waiting for Q and they will not go ahead. So this one will first get Q, then it will get S, both of them, it will not have to wait, it will finish, it will release Q and S, and then after that P1 can get it. So just change the order of S and Q here, S and Q here. First you get Q, then you get S, then you signal Q and you signal S. Okay. So any process, you can change this process or you can change this process, and there will be no deadlock. You understand? Okay. So we can change just the order of the wait and signal. Any other question? If you want to understand any course in general, it's better that you read the book sections for which I have slides. So you should see the Peterson's algorithm, for example, in the book. Okay. maybe the total slides, all of them, they are 50 pages in the book. But if you study from the start of the semester, it's nothing big. You should make your notes. The book is with you in PDF form. Okay, so there is no problem if you read the book and see, maybe you find some other examples. In the slides, I don't give many details. Okay, it's not possible for a teacher to give you details from every slide. So, do you have any question? Yes?
Slide 31.
31, last slide. This one. This slide? Yes.
For example, project priority and above normal, where less scale. Normal between the number priority in rows. The priority class is columns. So it should be 9.
I don't understand your question at all. I cannot hear you. There is problem with the mic. You can repeat. You said this is the table. You see the table, right?
Yes.
Okay. In this table, let me explain this. You have one type of priority here, which is real time, high, above normal. This is the classes of priority. Okay. And then this is the another one. Okay, which is the type of processes also. So time critical, highest. So time critical, they can be real time, or time critical, they can be idle. So you can see if a process is time critical and it is real time, then this is the highest priority, 31, which means this is the most important. Okay, so we will give this one priority, and after that the next one is this highest priority, and so on. Okay, so any number which is more, it will get more priority. It will be the first one in the queue, and the one which are here, they will just get time if there is no other process. Okay, now do you have a different questions? I don't understand your question.
Yes, lines.
Which line?
Table. Good and number 10. It should be 9.
This one? This one? Okay, it's not important. You don't need to memorize this. Okay, this is not for memorize. I will not ask you to memorize this or give me number. Okay, I can ask you that I have, for example, the question can be, suppose that I have time critical and real time process and another process which is above normal and normal. Okay, for example, which one is more important? Okay, so you will say that yes, this one is more important. Real time, time critical is more important than time critical and below normal. Okay, I will not ask about the number. I will just say that real time is more important than normal. Okay, and above normal is more important than normal, for example. Okay, so I don't expect you to remember all those numbers. No, it's not important. Okay, you know here the difference between here we can see one core and two core. Okay, for the threads, how do you have multiple threads in one core? Okay, so this is the example when there is memory stall. So during the memory stall of thread 0, the core can be used by thread 1 and so on. Okay, so you already know about multi-level feedback queue. There are examples in the book. You can study the examples and also questions in the book. I did not ask you this, and I hope that there is no question about multi-level feedback queue, but in general you should understand about the multi-level feedback queue. Similarly, highest priority, lowest priority processes, you should understand these things. There is nothing difficult in my opinion. Whatever questions were in this chapter, I have already asked you those different questions about round robin or first come first serve, or the other type of shortage of first, etc. Okay, so just it's easy, throughput and average waiting time and waiting time, all those things by now you should know. So when I upload the solution, inshallah you will understand if there is any question. Although most of the people, they have already done it. Okay, so you've already got full marks, 10 for bonus and 10 for questions, but still I will upload the solution, no problem. Okay. So some students ask, for example, what type of question can we have from chapter 9? Okay, so if you see in chapter 9, do you see my slides, right? Okay, so here this is virtual memory. Okay, so here you see page 0, page 1, page 2. What I can simply ask here, just an example, that here you see that this page, wait, so if I say that this page 2, it comes here, okay, maybe, so this is in the memory map of the process, okay, so I will say this is my page 2 and this is my page 2, okay, here. So where is the reference of page 2? So in this case, if page 2 is only here, if page 2 is only here, okay, and page 2 is only here, then you have to draw, for example, page 2 like this, very simple, okay, that this is the reference to page 2. But if there is page 3, for example, let's say page 3 is here and page 3 is here, okay, and page 3 is here, then you will make a reference that page 3 can come something like this, okay. It is not in the main memory, okay, it is in the backing store. So you will just choose any slot and you will say page 3 is referencing from this memory map to this slot in the virtual memory. You understand? Very simple, there is nothing difficult, okay. The other questions that can come here are about just wait, let me show you, for example, this one. Okay, what does it show you? That you have this logical memory, okay, of the process, which has these pages A to H. Then you have a page table, okay, which will reference this page number. For example, page number 0 is in frame number 4, okay, and some pages, they are not in main memory. So if I ask you to load page, for example, D, which is here, not here available, okay, and page E, so you can load it anywhere. Maybe you say that this page D, it is here, so you will write D here, and then 3, okay, it will contain this. Where should you put 3? Somewhere here. So D is frame number 3, and if you put it here, so this 3 will become 3 and this I will become V. It will become valid because D is here, which is frame number 3, and frame number 3 is for page number 3, D. So you will put 3 here and you will make this V. Similarly, for any other page, if I ask you that load page G into anywhere, so you can load it here or you can load it this position, and you can update this page table according to the logical memory. Is it easy? Any question? Yes? Okay? Yes or no? Yes. Okay, let me go to other things, okay? This is just an example, there is nothing in it, but I can go to, for example, the page. Yeah, this is very important. Page replacement algorithms and how do we use these algorithms, okay? So although this one is the same, but I will come here to the algorithms, this one, okay? Somebody asked me that how do we use these algorithms. So in this case we have this string, this is called the reference string, okay? In the exam I can give you a different reference string. So it can be, for example, 1, 2, 3, 4, 0, 4, 5, 6, something like this, okay? This is a reference string I will give you in the exam, and I will ask you that using the reference string, how can you use first in, first out? So the string will be different, you will have a different string, and you will draw something like this. How many page faults are there for the string? So you can generate a page fault like this, and at the end you will say if it is 15 or it is 10, okay? Or I can have a comparison that I give you one reference string, okay, and I will tell you which algorithm is best, first in, first out, or maybe least recently used or optimal algorithm. So you have to tell that. You have to use the string for both algorithms, and you will find the page fault for both, and the algorithm which has less number of page fault, it will be the best one. You understand? So this is how it will be working like questions can come in the exam. Okay, so there is nothing else. Any other question?